Students, before we start exercise 2.4, let us understand what is factor theorem. Okay, I have written here factor theorem. So before I go to this, let us remember the remainder theorem that we studied in the last exercise. Remainder theorem. Let us remember this. There is a polynomial p of x and its degree is n. What is n? N is the degree. So this n may be 1 or bigger than 1. That means we can write greater than or equal to 1. So that means the polynomial should be linear or it may be quadratic. So the minimum power should be 1. The degree should be 1, the degree should be 2, the degree should be 3, but degree should not be 0. That is what it says. There is a polynomial p of x and degree is n. But what kind of n? This n value is, it can be greater than or equal to 1. It may be 1 or it may be more than 1. It may be 2, it may be 3, like that. When it is divided by x minus a. When p of x is divided by x minus a. This remainder will be given by p of, when it is minus a, we have to take positive a. This is what we learned from remainder theorem. But now it comes to factor theorem. What it says, if a polynomial p of x of degree n greater than or equal to 1. So the same thing here, there is a polynomial and degree is n. But this n value, it can be greater than or equal to 1. That means we are talking about linear polynomial, quadratic polynomial, cubic, and more than this. More than, in a sense, minimum degree should be 1. Degree can be 2, degree can be 3, degree can be 4, but degree 0 we don't consider here. That means we are not talking about the constant polynomial. Okay, and a is a real number. So what is my real number? Real number means it may be natural number, it may be whole number, it may be integers, it may be fractions, rational, irrational. This set of numbers is actually what we call real number. So it says that x minus a is a factor of p of x if p of a is what? 0. What does it mean? If remainder is 0, then definitely this x minus 1 is a factor of p of x. So I'll tell you the meaning. There is a polynomial p of x. Now you're finding the value of p of a. Now you get here 0. It means that x minus a is a factor of this p of x. See, when 12 is divided by, let me say 4, 4, 3, 12. Now you get remainder here 0. That means 4 is a factor of 12. So like that, when you find p of a, if p of a is 0, then you can say that x minus 1 is a factor of this p of x. The second one, if x minus 1 is a factor of p of x, then p of a is equal to what? 0. If x minus a is a factor of what? P of x, then what happened? This p of a will be how much? It will be 0. So this is all about the factor theorem. Now we are going to start 2.4. Question number 1. Determine which one of the following polynomials has x plus 1 as a factor. So there are a lot of polynomials given in the question. And now we have to identify whether this polynomial has a factor x plus 1. That means whether x plus 1 is a factor of this given polynomial or not. Let me repeat, we have to check whether this x plus 1 is a factor of the given polynomial or not. Now let's start the solution. Let p of x equal to x cubed plus x squared plus x plus 1. Okay, so this is x plus 1. Now let us find the 0 of this x plus 1. The 0 of x plus 1 equal to minus 1. Very simple. When it is plus 1, it becomes minus 1. Okay, so now let us find p of minus 1. P of minus 1 means, in a sense, we have to understand the remainder. Accordingly, we have to decide P of minus 1. So wherever you find x, you have to replace with minus 1. So x is minus 1. So minus 1 whole cube plus minus 1 whole square plus here minus 1, then here plus 1. Minus 1 whole cube, it will be minus 1. Now what happened here? The base is minus. And now let us check this power. If the power is odd number, minus will be here. If the power is even number, then this minus will be definitely changed into plus. So now plus here 1, then plus into minus, minus, then plus 1. Now minus 1 and plus 1 you cancel, again minus 1 and 1 you cancel. So what do you get now? You get here 0. So from factor theorem, this x plus 1 is a factor of this. That means you can write x cube plus x square plus x plus 1 has x plus 1 as a factor. Now we have completed the first one. After this, we'll be doing the second one. Let p of x equal to x to the power 4 plus x cube plus x square plus x plus 1. Now the 0 of x plus 1 equal to minus 1. Then let us find p of minus 1. P of minus 1 equal to minus 1 whole to the power 4 plus minus 1 whole cube plus minus 1 whole square plus minus 1. Then last we have plus 1. I'll write here. And we have here 1. From here, minus 1 whole cube means we will get minus 1. Then minus 1 into plus, you'll get here minus 1. Then here we'll get plus 1, plus into minus, minus 1, then here plus 1. Now plus 1 and minus 1 we cancel. Plus 1 minus 1 we cancel. At the last we have here how much? 1. So here let's see. From factor theorem, here the remainder is not actually 0. Remainder is not 0 means this is not a factor. So you can write here x plus 1 is not a factor of x to the power 4 plus x cube plus x square plus x plus 1.